All right, let's do a couple of examples here. So we want to see if what these are symmetric with respect to, right? So what we're going to do is let's take A, and what we're going to do is replace x with negative x, right? So let's do y equals the absolute value of negative x, okay? And so if we simplify this, this gives us what? Y equals the absolute value of -1 times x, which then we can use the properties of absolute value and we can split this up into -1 times the absolute value of x, which then gives us the absolute value of -1 is 1, right? So that just gives us back x. So we basically get y equals the absolute value of x again, which is what we started with. So this tells us this is symmetric with respect to the x-axis, right? Which we should know because this is our basic function, right? So if we understand what the behavior of this, like we should, then we can just know when we see this, hey, we know that this is symmetric with respect to the y-axis, okay? Because we know the graph. Okay, but yes, it's good to be able to test it algebraically too. Okay, now, what about replacing y with negative y? So if we do negative y equals the absolute value of x, and then let's say, let's multiply both sides by -1, and we get y equals negative absolute value of x. Well, there's no way we can simplify that any further, and so we don't get back to the original equation, so this is not symmetric with respect to the x-axis, and we already know that because we know the behavior of the parent function, right? And then let's do both, let's replace both with negative, right? So negative y equals the absolute value of negative x. Well, if we simplify this, all we're going to get is the negative y is equal to the absolute value of x, and we already did this one. So this is not going to be symmetric with respect to the origin either. So, in conclusion for part A, this is symmetric with respect to the y-axis, and that's it. All right. And we know that from the graph because the graph, as we should know, looks like that. Okay? And so if you can see it's symmetric with respect to the y-axis, but it's definitely not symmetric with respect to the x-axis, and if you rotate it 180 degrees, you're not going to get the same graph. Okay? All right. So now, what about part B? Okay, so now let's do, let's replace x with negative x. So let's write this as negative x equals y squared minus 4. Well, there's no way to simplify that, where we're going to get the same equation back. Because even if we multiply both sides by -1, we're going to get x equals 4 minus y squared, which is still not the same thing. Okay, so it's not symmetric with respect to the y-axis. Okay, now let's replace y with negative y. So that's going to give us x equals the quantity negative y quantity squared, right? So again, remember we're taking the opposite of y, and y is inside the square, okay? So minus 4, so be careful of that. Now, let's simplify this. Well, again, if I do this algebraically, I can write this as what? -1 times y quantity squared minus 4, and then of course I can distribute the exponent, which is going to give me x equals -1 squared times y squared minus 4. And then of course -1 times -1 is +1. And so I get x equals y squared minus 4, which is exactly the same thing I started with. So this is going to be symmetric with respect to the x-axis. Now, if I replace both with the negative values, right? So if I were to say -x equals -y quantity squared minus 4. Now here's the thing. We already know what's going to happen here. This is just going to become y squared. This isn't going to change. So I'm going to get -x equals y squared minus 4. And as we saw before, we can't do anything with that. So in this case, it's not going to be symmetric with respect to the origin. So this equation is symmetric with respect to the x-axis. This equation here is symmetric with respect to the y-axis. And that's it. All right. We'll come back with another one.